to say or not to say.
If you want, we can post it on YouTube. But I would rather make it for the people in this hackathon, because we're gonna go relatively deep into how to support you. So maybe I can cut a very small part of this video for larger publishing. But
Okay, yeah, just wanted to know.
I think it'd be nice for the next Hacknight to show how we are here, how you can talk about the hackathon, so you don't have to repeat everything as well, every time. So that's why I would like to hear you more. And just as an intro, very quickly, I'm going to share my screen. We are here with Peter Rose from UCSF and the SPOKE Knowledge Graph, Mike Dillinger from Hypergraph.ai, and Steve Hedden from Tech Quadrant. And this is almost the same team as last time, but Charles couldn't make it. So we're just at the beginning of the exploration of the SPOKE Knowledge Graph. Last time the goal was to understand the different data sets and structuration of your knowledge graph, Peter. So we found the links, we explored, and we found out some of the ways we could help you. Our goals were to find, last time, 3 weeks ago, find out where there would be gaps into goals that you can achieve with the SPOKE knowledge graph, how the people here assembled, and in the future with this resource group for KGC and the community at the Knowledge Graph Conference can help you, can hack something for you, build something together, co-create. And so the goal was to understand both at the tech level how the knowledge graph was structured, and in terms of domain, how we can support, and where there's potentially more data we can add there. And then once we had these ideas, we mapped these ideas to a knowledge graph lifecycle stage. This is how the resource groups are organized at KGC. And so we ended up with this. I'm sharing my screen here. It's probably a little bit small. I'll make it a bit bigger. We had data servicer ideas for APIs and how to query. Charles, who worked with you already in May, in the hackathon in May, remember that there were an API, a set of APIs for querying. He was thinking of filter logic for mitochondria as a data servicer. Other kinds of challenges that we could address in the future for SPOKE is data enhancer. So how to enhance, enrich the data. 3 ideas here: prepare for harvesting, pathways to model, and we can get into some details if you have questions. But then another one was to chain data sets together in a more reliable way, and map SPOKE, finally map SPOKE to the metabolic atlas. Another kind of challenge that we thought about was how to support, enhance the design, the architecture of the knowledge graph itself, maybe a use case for a hypergraph, TBD. And we're glad to have you today because we really wanted to talk to you. That was one of the main next steps. So welcome. And I'm sure you have some questions or feedback on that. Peter, I'd like to hear you a bit more.
Yeah. I mean, I think one of the problems is that you really haven't talked to us. So in terms of SPOKE, as you probably know, there's a company called Mate Bioservices. They are further developing SPOKE. So the SPOKE knowledge graph is really proprietary, although there's a public user interface, you can query it, but it's really, a proprietary platform. So my suggestion is let's don't focus on SPOKE, but they're more focus on what the NSF is doing with the Proto-OKN project. I don't know how familiar, I guess you are familiar with it, Hugo, but I'm not sure about the other folks. And that includes some aspects of folks and another GeneLab and so on, but also, the idea is to do federated queries across like 20 or more different knowledge graphs that are hosted on the FRINK platform. I'm not sure how much you guys know about that, but I would suggest to now move a little bit towards that side, because that's, I think, where we could make impact. Where with Spoke, there's a company behind it. They just hired whatever CSO and so on. So that's well underway. I don't think there's much we can contribute to that, especially if you're not a bioinformatics person, and really know what's required there. So I would suggest probably focusing more on the technical side of things, and maybe I can give a little review what FRINK is, and maybe some other alternatives that we could create a new knowledge graph and things like that. I don't know, would that make sense?
It would for me.
Yeah. So I'm sorry that stores moves a little bit away from Spoke, but I don't see that as a gap, since there's a company behind Spoke developing it. So I don't think,
Yeah, yeah,
at
yeah.
least that doesn't make much sense to me.
Okay, sounds good. Well, this is great to have you here. If we can support the Proto-OKN program, Spoke being a Proto-OKN, I assume that it was what we could support. But if we can support FRINK rather, so
Yeah.
FRINK is another Proto-OKN, part of the same program at the NSF, and FRINK is a way to leverage the different knowledge graphs. So what you're telling us is we cannot directly support the knowledge graph itself, but rather APIs or ways to leverage the knowledge.
Queries, visualizations, and gaps. I can maybe mention what some of the gaps are and so on.
Sure, I think the FRINK team actually is what's his name?
Chris Bison.
Chris Bison is also interested in getting our support by other means. But if you have specifically for Spoke, specifically for leveraging Spoke through FRINK, maybe since you're here, can we still try to focus on bioscience? Maybe.
Yeah, right. And maybe we should really, or you get in touch with the FRINK people, to make sure that makes sense to them too. I don't want to speak for them, but I can give you a little introduction what FRINK is and what kind of knowledge graphs we're currently hosting there and how we query them. I can show you a little bit that, and maybe also some of the issues with it. If that's of interest, I can do that.
The issues are very important for us to think about.
Okay, so I share my screen and walk you through some of that.
Thank you.
Okay, so let me share, let's see, entire screen. Doesn't let me share. Here we go. Okay, let's see. Share. Okay, so let's see. I don't know. Have you guys heard about the Proto-OKN initiative at all? Or?
Only a little bit.
Okay, so let's see if we go to explore. I mean, the idea is, there are about 20 or so projects that develop knowledge graphs, and the FRINK platform is hosting those knowledge graphs. And now we need to be able to run queries on it and do federated queries across multiple knowledge graphs and things like that. If we
Can you tell me what you're calling federated queries?
Yeah, I mean, across multiple knowledge graphs. I said there are about 20 of them, and I'll show you that. And let's say want to run a query across multiple of those. Does that make sense?
So does that work in a context where, for example, the relations have different labels in different resources?
Right. Yeah, right. That's actually a good issue. That's actually gap number one.
It's my favorite issue.
Yeah, that's exactly one of the issues. The FRINK team has started working on that, but the data they try to align data, but it's in the very beginning. So that's definitely an area of where they, I think, could use help. And again, I have to also say that I'm not an expert in Sparkle or RDF. So I come from the Neo4j property graph world. So this is also a little bit new to me, this entire Sparkle in RDF and so on. But anyway, those what's called the theme one teams, and they're listed here. You can see what the different knowledge graphs are here. Spoke, there's BioBricks, and many other. They come from different. So see, in terms of bio and health, there are those two knowledge graphs. They're ordered by different areas. Environment here, and then there's what else? Justice and so on. So technology and manufacturing. So they have knowledge graph from different areas. But let's go to the FRINK website and let me show you what's available there. So this is the FRINK website. Maybe should I share those links?
Just a quick question. We were looking at this, I think the last time. We had it structured as 3 layers, and there was one you were showing with all these 20 knowledge graphs, and then second was about that layer. FRINK was one, and there was another one called Spider.
Yeah, right. Yeah, so the way I understand Spider works, they just use APIs. For example, Spoke has an API, so they're accessing the API, but they don't try to, put this all into RDF and so on. They basically just use various APIs to kind of combine the data. But again, I'm less knowledgeable about what the Spider folks are doing.
Okay.
Yeah, so that's why my question came up, because it sounds like they're federating queries or connecting via APIs only based on the nodes or node labels or node IDs. And sounds like there's less attention to the semantics.
Yeah, again, I can't really speak for Spider. I've never seen it, or
Okay.
I don't know much about it at all.
Okay.
So those are, I guess you guys have seen that those are different knowledge graphs. They added a few new ones here. They don't all work yet, although they're listed here. Some of the endpoints don't work yet. But let me go to the 2 that I was involved in, and there are 2 of them. This one is called SPOKE GeneLab. So this is our collaboration with NASA, where we integrate transcriptional profiling and DNA methylation data that come essentially from space flight, like from the International Space Station and so on. So those are called the NASA GeneLab data. They're in here. And then we have the SPOKE OKN. This is a subset of the commercial SPOKE, a very small subset that focuses on things like environmental sciences, like contamination in various areas, like those perfluorated compounds that are building up in various places, and chemical spills and that kind of thing. Usually those data come from the EPA. And it goes a little bit also about social determinants of health, how social determinants of health, can influence health. So that's also in there. And so initially they started out as Neo4j property graphs, and I can show you how the schema looks like. Let's start with the SPOKE GeneLab, which is very simple right now, because NASA it takes time for them to prepare the data set. So we're not so NASA has a website called GeneLab, but that hosts, the original raw data, but then they process the data to create processed data. And in this knowledge graph, we only include processed data. And there are 2 types of processed data. One is differential methylation data, and the other one is differential expression data. So in the future, there will be newer data sets coming, but it will take time for them to process and develop platforms to process the data. So that's why there's not much in here right now. But just to the way it's structured, there's a mission that is like some SpaceX mission, for example, right? They conduct a study, and that study runs some experiments. We call them assays, and they do some measurements here. They measure some genes, or they measure DNA methylation regions, and so on. And then we try to map those entities to, for example, the assay, what organ or what kind of cell type was used in this assay. So it's linked to anatomy. For example, okay, they analyzed something in the liver, a liver tissue, or a particular kind of cell type was analyzed here, And then for the genes, most of the data we're getting from the International Space Station is mouse genome data instead of human. But we can map, actually mice and human are very similar, although we don't look very similar. But the mouse genes, many of them, we can map to the human genes. So those are the human genes, for example, here. So another aspect of this knowledge graph is this called the meta node. So the meta node is this is a self-describing knowledge graph where each meta node describes exactly what are all the properties of an assay or an M gene or study, as well as those relationships, their properties. They're all described in here. So when we run this query in Neo4j, it knows a lot about the entire schema, what all the properties mean and so forth. So unfortunately, we don't quite have that yet set up in RDF. So that's the GeneLab schema. And as you see, it's pretty sparse. There isn't too much information in it. So this has about, I think, 100,000 nodes and about 13 million relationships in this knowledge graph. Any question about this one? Okay, then I go to the next one. Let me see. I thought I opened that one already. Let's see. That's not it. Thought I took a screenshot of this. Spoke OKN. Okay, that's this one here. So this Spoke OKN knowledge graph is a small subset of the entire Spoke knowledge graph. And what do we have here? First, we have organisms here, like that would be human or mouse and so on. This is compounds, chemical compounds, and they have some relationships here. Then we have genes. We have diseases. For example, if you have some mutation in your gene, it probably is the cause for some diseases here. Then there's some mortality data that relates diseases to specific geolocation, I think mostly in the US. And then there are also social determinants of health and how they affect diseases and also what locations they are, so. And then we have a few environmental factors too that are tied to location data. So again, there isn't much data in here. So it's not the whole Spoke that maybe you guys were thinking about with pathways and so forth. So this is very limited. That's why I'm saying this main Spoke, there isn't really much you can do with that since there's somebody else working on that already professionally.
Peter,
Yeah.
quick question about this since you were involved in it. How does validation and double checking the consistency and coherence of these triples, how does that work?
Yeah, I mean, this is still the Neo4j knowledge graph, and that information is extracted from, I don't know, 50 or more biological databases, and integrated and, harmonized and so forth.
But we're assuming that the original databases are correct.
Yeah,
and that the representations are coherent.
Yeah, right. And they're not always correct, but they're probably 99% correct. Those are curated data sources that are used by thousands of biologists, I mean, they definitely has errors, but that's the real world.
That's not I'm talking. I'm not talking about the measurements.
Mm-hmm.
What I'm talking about is the vocabulary of relations.
Mm-hmm.
So it's really simple to have similar relations in different data sets that have different labels.
Yeah, right. I mean, we analyze the raw data and harmonize them so that those relationships that we show you, that they make sense. So this is something we define. Yeah. So this is still what I just showed you now. This is kind of the Cypher implementation, but then the FRINK team has converted those to RDF, and they can be queried through their Sparkle interface. Let me see if I can find that. You probably have seen that, I guess. I know. Have you seen that? That is this link here. So that's their Sparkle. They have a federated query here, which queries across everything, or you can choose, a particular knowledge graph from this list here. Again, some of that isn't quite working yet and so on, but in principle, that should work, So that's what they provide. This is obviously not very user-friendly enough. They have let me just run some query here, some example query. This is really not human readable. That's not really useful information, right? So what I've been working on, and maybe I'll show you a little bit of that, is MCP services that run on top of FRINK. So I guess you're probably all familiar with the MCP principles, right? Or should I explain that? Or?
Can you remind me?
Sure.
Yeah, so let's say you're using ChatGPT. You can use various tools. For example, you can tell, okay, search the web and find me something. So that would be an example of a tool use, where it's not just using the LLM, but it's using a tool to do something. Or it may write you a program to do some calculation for you, you know. So those are an example of tools. So what I've done here, I provided tools to query the FRINK endpoints. And yeah, let me just show you how this, so this I'm using Claude Desktop here to do those searches, because here you can integrate tools. Let me show you how this works. So if I go to settings here and connectors, you see you can connect that to your Gmail and so on in your calendar. It can probably, you know, delete all your emails or whatever, a kind of scary connector. So I don't use them right now. But those are the FRINK endpoints here. So they link to those Sparkle endpoints in FRINK. We also have a few endpoints like those. They link to Cypher, but they link to Mate Bioservices. So this is commercial, so you won't be able to run those since, you know, you don't have access to that. But anyway, let me just show you an example here, this remote Cypher, the GeneLab one. We go to configure. You see this particular MCP service had a number of tools. Now this runs Neo4j. It can get the schema of Neo4j, can execute queries. And then I mentioned those metadata that we're having. So we can get node metadata and relationship metadata. And it has some special tools, for example, to find down-regulated and up-regulated genes. So those are some tools I generated. Again, this is now on Cypher, but maybe let's just look for how things work on the Sparkle side. So let's go to Spoke GeneLab. So there isn't much there. It can can execute a Sparkle query. It can get a schema, which gets all the classes and predicates from that knowledge graph, and it can get a description of that knowledge graph. So those are the only tools currently available. And then we can ask it some questions. So let me see here. So Protein Sparkle already ran some queries. So for example, I was just talking to one of the other teams this morning, and they created this knowledge graph called SAW graph. And I really don't know what it's about. So I asked this MCP service, create a 1-paragraph description of this knowledge graph and its content. So it came up with this description here, and it's using a tool, Get Description. That's one of the tools that I created. But this was a little generic for me. I said, look at the actual data and make it more specific. So then it ran 2 queries here. You can see those are the queries it generated and the results that it returned back. And so it ran 2 queries. And now it gives me a more specific summary here, including some numbers and things like that, you know. So, you know, this is just using MCP service to query a single endpoint, but I can also query across multiple endpoints. You know, I can say, okay, look up this information in this knowledge graph, and then use that data that you retrieved there and maybe correlate that with other information in this other knowledge graph. So that's what I mean, you know, with the federated queries here. So, but let me talk about the limitations. You know, I mean, it kind of works, but it doesn't work very well. So, for example, if I go to Spoke GeneLab, if I ask it, what's your schema? It tells me this. I say, okay, get the schema of this Spoke GeneLab knowledge graph. It calls this tool get schema. And it says, okay, there are 9 classes, there are cells and missions and assays, etc., etc. And then it finds the various relationships. Those are the same ones that you previously saw on the Neo4j knowledge graph when I showed you that schema there, right? And then it lists the various properties that are also available here, you know. So this is pretty good. But if we go to other knowledge graphs, let's see, let's go to BioBricks, for example. They did map that to various ontologies here. So it says, okay, those are the classes here. And, you know, this get schema, let me show you what it actually retrieves. So it basically gets just the URIs of the various classes here, as you can see here, you know. But it doesn't have labels. So, you know, this MCP or whatever, the LLM, doesn't really know what to do with it. This bio, so this one here, it says it's a bioassay ontology term. That's nice, but what does it mean? So
Right.
you know, that's a gap here that currently I don't have that info. That information is not available in the RDF file. You know, so that's actually one of the biggest issue here. You know, and that all comes back what you asked earlier about aligning the different knowledge graphs. You know, so
Exactly.
they're working on it. But again, what I need, it's not enough to say, okay, that's this ontology term. I need to know the label and I need a definition of that to do anything reasonable with this
Useful.
query,
Yes.
right?
And who did
So-
you say is working on this?
Yeah, that's the FRINK team. That's Chris Bison
Okay.
and Jim Belhoff are their names. I don't know if you
Okay.
heard about those folks, you know. I
So-
mean, we can definitely try to set up a meeting with them because I mentioned just earlier this week, I mentioned that to them that, you know, for an LLM, I mean, I don't know what that bio is. I can probably Google it and figure out. But the problem is this bioassay ontology is only available in an OWL file. So I would need to go to that OWL file and then inside find this particular class and so on. You know, I mean, that you know, I mean, it can be done, but you know, it'd be better if that information will be available straight away somewhere, so I can just, if I get this particular URI, okay, I know that means this, and here's a description, and the LLM can, you know, do some intelligent query about it. But this way, so I can still do queries, but you know what this LLM does? It just does basically various full text queries of that knowledge graph to figure out whatever kind of compound I'm looking for and so on. So it can still do it, but it's just like a wild goose chase trying to find information
Exactly.
doing some very generic searches rather than something specific, you know.
So I think what you're saying is it might be useful to generate an index on top of these,
Right,
each
exactly.
ontology.
That's right. And let me show you, they started trying to do that, but they never actually implemented it. So let me show you what the FRINK team tried to do. Let me see if I can find this maybe in here. So if you go to this registry here and click on any particular knowledge graph, maybe this one here, you get more details, and it has this one here, the FRINK graphical summary. If you click on that,
Okay.
I think this may be out of date anyway, so that's another issue that I don't think this is up to date. But there's a schema here, and if you look below, it defines what those classes are, but there's never any description. So for all knowledge,
I noticed
this is empty in the same what they call slots, I guess are the predicates. You know, there's no description
exactly.
either. So
yeah, I went through that and I noticed that there are no descriptions anywhere.
Exactly, right. So I mean, if as a human I don't understand what this BAO 15 is, how can the LLM understand it? You know, so
LLMs don't understand anything.
Yeah,
okay,
that's right. So that's the biggest issue. You know,
all right.
in case you think, oh, maybe that's something I can help with. You know, I talked to the FRINK
Yes.
guys, I don't know, a couple of days ago, whenever, and they mentioned that, and this is what I think, I'm sorry, I forgot your name. Anyway, you mentioned the shackle.
Mike.
Right?
I'm Mike.
Mike. Oh, okay. You mentioned the shackle, right? So they were suggesting maybe what we need is shackle for defining that. And again, I'm not an RDF guy. I don't know the details about shackle, but is that a way to define that?
Yeah.
Yeah.
It is actually.
Yeah. So
I think of shackle as a way for validating triple statements, for example.
Yeah. Yeah. Okay.
And templates for creating them and these sort of things.
Yeah.
It's a sort of a meta language for describing triple statements.
Yeah. Right. Yeah, I mean, I think that might be one area if you guys interested in. I mean, we definitely should talk to the FRINK team about it so we don't overlap, you know, so it's more complementary. And I don't know if they even have expertise with shackle. I don't really know. But I think that will be one area that if you really want to help with this project, that would be, you know, a great addition, I think.
And I think having talked to Chris Bison recently, he's very, very interested in supporting our community. So we had a quick discussion about this, and this might be an example of what he wants to achieve. So as we're going, forward in this Hacknight, I would just like to make sure that any enhancement that we had talked about for Spoke has to be completely rejected, or if you would like, the team that is currently driving it into a business might still want to leverage the community. We just need to, in that case, sign agreements. So it's possible. It might be too complex for you or not the right timing, but it's possible to do that. It's designed for supporting startups as well.
Yeah, right. But I mean, that requires, the deep knowledge, in the bio area, and I'm not sure we have that here. So
we're inviting domain.
It also requires deep knowledge and knowledge representation.
Yeah.
Which I suspect is missing in many cases.
Mm-hmm. Yeah.
We're seeing that to support the enhancement of knowledge graphs, we need to combine the different domain expertise and technical expertise at the same time. And these events where we can bounce ideas seem to be the way to go, the way to develop. And that is something that large companies are currently really liking, to train their learning engineers. So in biotech, in life sciences, there's companies beginning to pilot how to leverage what we're doing currently for their teams to train the data scientists, to have these kind of discussions where someone can drive the technical discussion and someone else, picks this with the domain expertise, and that's useful usually. So we are working on inviting more biotechnologists or researchers in life sciences, generally speaking. So if you'd like to, with Spoke or what it has become now, leverage this, I would love that. But definitely, first of all, we can try to support FRINK, who I know is open to that. So with this little digression, you can do what you want with this, but it's a call for action for later if you want. Have a little bit of notes. How would we go on knowing that Chris is not there? I can still send a quick email, but I doubt he's going to join at the last minute like this. So is there anything that you, Peter, you would suggest we try to define the challenge, and then we validate that with Chris?
Yeah, I mean, if we want, if Shackle is the right technology, we could maybe use the Spoke GeneLab and Spoke OKN knowledge graph to create those Shackle files just to see how that looks like, and maybe I can even try to use them in the MCP services then, I mean, as a prototype, we just try something before we say to Chris, oh, maybe we can help you. Maybe if we had a little example, how does that sound?
Was it?
Sure.
Yeah.
One of my goals here, and I know Hugo and I've talked about this, is trying to identify places where our help could be most effective.
Mm-hmm. Yeah.
Right. So this is why your input is really valuable for us to see. This is a problem. Cool. Something we want to think about.
Yeah. I mean, we need to get away from the Sparkle queries, because I don't know what percentage of bio people know Sparkle. I don't. So.
Mm-hmm.
And really, these days you need a natural language query. There's no way around it.
Yeah,
and it needs to.
We have LLMs that are working fairly well for that.
Yeah. Mm-hmm.
So I don't think that's as challenging a problem as the other one that you mentioned, which is actually getting the data to integrate.
Exactly right.
So we can get past mismatched labels.
Yeah, right. And semantics with labels and descriptions, because the LLM needs context. If it just says bow 15, okay, then I know what that is.
Exactly.
Yeah.
Exactly.
Mm-hmm. Yeah. Yeah. So would that make sense that we maybe try to create a Shackle file? I have no idea how they look like, but maybe
So Shackle files can be templates for types of triples, for example.
Mm-hmm.
Right? So this is how I've seen it used, that I think is interesting. So if you have a type of triple with a given relation in it, the template can actually define the arguments that it can take and not. And as that set of Shackle statements, you can use to validate whatever it is that you have in a legacy format.
Oh, I see. And how does the shackle file interact with the Sparkle query itself? Are they linked, or is that two separate technologies? I don't quite understand how this all works.
I'm not sure I can answer that right now.
Mm.
So I think I've seen shackle used to validate the query.
Yeah, right. But
Okay, to see if
yeah.
there's a problem with it.
Mm-hmm.
Okay.
Yeah. And I could use it in the MCP services to give context to the LLM, so it knows what things mean, and then be able to do better queries.
That's the part I'm interested in.
Yeah.
In finding ways to pass along what these things actually mean.
Yeah.
Instead of raw IDs.
Yeah. Right. Yeah. So as far as Spoke GeneLab is concerned, we have all that information available. Let me see where it is. And maybe I'll show you if you want.
Speaking of shackle, I'll just jump in. I mentioned Top Quadrant's a shackle shop, so our engineers are definitely shackle experts. So that's expertise, not me personally, but our team they're in the W3C working group right now. The next version of Shackle, for example, and one of our lead engineers, Holger, is the original editor of Shackle, so he's definitely the most knowledgeable person on Shackle specifically, and we use it for a lot of those data validation problems. And
right, that's what I.
Yeah, I mean, and really just defining ontologies generally.
So I would actually say designing the ontology, so you can populate it more systematically. Steve, if at some point we can follow up on that, I'd really like to know more.
Yeah, absolutely. And just another plug what we're working on also as an MCP for this exact what you just described, Peter, of being able to ask questions directly, generating Sparkle queries, and then integrating with OWL. And so we're playing with different use cases there, because a lot of people historically have used OWL and it has a lot of benefits, but how those two things interact. So an example could be an OWL high-level ontology for inferences, and then shackle constraints per domain. So you have multiple different shackle ontologies kind of underneath one larger OWL thing.
Should I show you guys maybe the metadata we have for this Spoke GeneLab database, how we define all that?
Yes.
I mean, that's in our custom format, but anyway.
Any definitions you have, I'm interested in seeing.
Yeah, okay, let's do this. So let's see, entire screen. How does that work? Okay, here, share. So let's go to the GeneLab website. Let's see. I forgot where that stuff is. Okay, here. So this is actually the code that basically what this code does. The GeneLab at NASA, they have an API, and this code here uses the API to extract the data and that Neo4j knowledge graph that I showed you before that looks like this. So there's some Jupyter notebooks in here. They extract all the data and massaging them and so on. But the way the knowledge graph is defined is in here. So we are at version 4 here. So there are metadata in here, and there are node and relationship metadata. So the node metadata, they look like this. Okay, let's say look at assay, for example. Those are all the properties and their types and a description of each of those properties of an assay, for example, right?
Right.
And then whatever. Let's look at this one here. This is now for methylation region. And then similarly for the relationships, we have also the metadata here. So let's say this one here, for example. So this is called measure differential expression, and it says so the from and to, those are the two things that linked together. That from is in case the assay, and it links to an M gene. So from whatever, that's a unique assay identifier, and to is a gene, and that's a GenBank Entras ID. Those are the identifiers. And then it has two properties. log2fc, which is this log2 fold change, and it had this adjusted p-value. And there's a detailed description, and it's very detailed. It's cut off here. I don't know if I can scroll over. It's long. And why it's so long is because this gives context to the LLM. Otherwise, if I say log2fc, I have no idea what it means. This is very detailed here about what it means if the value is negative, it's positive.
If it's a p-value, then it gives you a confidence score.
Yeah, right. And says this is about multi-testing corrected p-value, etc. So it has, exact details, what a typical cutoff value is, less than 0.05 and things like that, So and this is what the LLM needs. If it gets this rich information, then you get rich answers back,
Right.
So so this is how.
So one thing I'm not seeing here is information about how this relationship is different from other relationships or related to other relationships.
Yeah, I mean.
So the relations here turn out to be a list rather than a graph.
Yeah, so now if you put all those things together, they go into Neo4j, and then they will create this knowledge graph out of it. So they will automatically create this schema out of that. So I mean, this is auto-generated, this schema from the properties,
Yeah. The only thing
it's just a simple scheme, where
it is
basically the name of the node is just the name of the file name, basically, right? So that's just the name of the file name. And the actual data files that we're importing to create the database is actually using those two. So to make sure the data fits with that definition, right? And then the relationships you can see again from here. So that entire knowledge graph is just completely generated out of those CSV files. This basically defines the schema of that schema. There's those files here, it's just using the names straight from the file name here to create that.
Right.
So would this information be useful to create a shackle file to define those terms? Is that kind of what you would?
So that's the definitions that you have inside of the relationships are kind of an informal shackle statement that will define statements with that contain that relation.
Yeah.
So that's how I would start with it. Steve, does that make sense to you?
I think so. So at a high level, Mike, is that you're saying shackle would be sort of like a way to connect these knowledge graphs that are pretty self-contained. You could use shackle to connect them.
What Peter is showing us was the different components of a relation. Okay, so you have constraints on the subject, you can have constraints on the object, you have different properties. Okay, and we could use shackle to make a template of that and say, oh, this is this kind of relation, it has this kind of here. And then we could even do things like subtype them, right? Or create other relations between the relations, which is one of my pet peeves, is we need to do more of that. But yeah, shackle would be the meta language for describing these kinds of relations.
Okay.
Or kinds of nodes, for that matter.
I need to step away for a minute, but please continue.
Okay. Yeah, it makes sense. I see Shadab, if I'm pronouncing that correctly, the question about Neo4j. I could see we recently have been developing a Neo4j integration, and so it's done some steps there, but I'm wondering if that could be helpful too. And since if you define it from the shackle constraints and then basically make a subgraph that you could send to Neo4j, but those relationships are defined to do the graph analytics on.
Yeah. You could probably use the shackle as a kind of bridge between RDF and Neo4j sorts of things. Right? We know all the components, we know the types of each of the components, the roles of each of the components. Then we could generate from that an RDF version or an OWL version or something.
Hey, Shadab, thank you for
for joining. And would you like to introduce yourself? Gaston, same thing. We're just a small committee here, so just don't hesitate. We can hear you. I thought you were speaking earlier, and I didn't hear you. Am I the only one here?
I can't hear him either.
Right. Oh, there we go, I think. Oh, that's Gaston.
Is that Gaston?
Yeah, that's me. I guess I'll go first. How's it going, everybody?
Hey, yeah.
How y'all doing? I'm enjoying all of this. I'm just absorbing and just acting like a sponge right now because I didn't make it for the first I guess hackathon night. So yeah, I'm listening, and yeah, I've been working a lot with the knowledge graphs. I actually finished up a project this morning over it, getting more on like the creative spaces with it. So yeah, listening to like the data sets that y'all are going to be introducing with RDIF is fascinating. But yeah, I just want to say my name's Gaston. I'm a ethical hacker, I guess you can say. I've been competing in a lot of events as of recently for this this upcoming year, and yeah, I'm just looking forward to like seeing what we can do with this. I still have to do a lot. I like to do a lot of R&D before I jump into projects, but this one seems like a very interesting one. So I'll keep my I guess my hand over this one. So yeah, nice to meet y'all, everybody.
Oh, thanks, Gaston.
Yeah, thank you. And he didn't say, but he was part of the team that worked on Spoke, the previous time in May, and they had a lot of fun exploring all that. There was a lot of data prep, I think, with the NASA team, and yeah, super team. I really loved to follow what you were doing, and you won. You won a medal at that hackathon, so congrats again. And Shadab,
Wow.
we've met last year in Georgia, in Atlanta. Nice to see you again.
Yeah, same here, Hugo. Thanks. Hi, everyone. Sorry, something was wrong with my AirPod because of which, like, I was not audible. So I'm Shadab, and I've been working in the industry mainly on the AI, Gen AI side. So I started my career as a data scientist, then switched towards the engineering side, solving and building and streamlining data pipelines for different clients. And for one of the clients, like, I don't have very extensive sort of data science experience as such, but mostly I've been focused on building applications or data products and AI products. So for one of the clients, like, we have worked on like building a graph-based application as well, where we had data from like the marketing team, the customer 360 view we wanted to create so that they can analyze the data. So that's where like one of the application where we ended up using Neo4j graph database and build the whole application on top of that and integrated that with Gemini model so that they can just query the application in a normal language and get the analysis and insights out of it. Outside this work, like, I'm into deep tech, so I've been doing some research in quantum computing as well. I have published a book as a co-author on financial modeling using quantum computing. So that's like something additional from like day-to-day work, like what I've been doing so far.
Wow, that sounds like fun.
Yep, thanks, Mike. Just a little bit, and here looking forward to learn from you all and see how meaningfully I can contribute to this.
Well, thank you. Such good energy, and I'm so happy to see you all here. I feel like I'm in with friends, just having an evening, just brainstorming about things we can do, and then hopefully we'll lead some other people to try out, to actually try to prototype something and join the next one we're gonna use, the next Hacknight we're gonna organize, and the hackathon coming up for a weekend. So November shall be the prototyping month. So if we could end up tonight with an idea that people could try to take for themselves to develop, it'd be really nice. And I guess that's your expertise, Mike, Steve, Peter. How do we formulate something like that?
I think first maybe we should talk to the Chris Bison and so on to see what their plans are, how that all fits in, so we do something complementary. And
that sounds like a good idea, Peter.
Plus, they should be aware that we're working on that. I don't want to be working in secret.
will not be secret. Okay, so then we can call it a night. I think we did a little bit of just harvesting some more ideas and details about what we can do. I'll share that with Chris. Try to organize a next one, and maybe just have a one-on-one discussion with Chris so that he gives us some details about what he can do, and share that with the community. How does that sound? And would you be available in like 3 weeks to follow up with this?
Yeah.
If you want, Hugo, if you want to include me in your conversation with Chris, I'd be happy to do that as well.
Yeah, the same with me. Maybe I should be involved in it too, since I've been talking to him about this stuff already.
Okay, so maybe so that could be the purpose of the next Hacknight. And how do we switch from this ideation to trying things together? We have the possibility, if we wanted right now, we could go to the app and make some teams and join others of these rooms that we've joined right now, and we can break down the work in small teams. So that could happen as the second timing of the next Hacknight, if we're addressing the what to do fast enough. But I'm not sure if it's possible. Maybe we need a lot of R&D for really understanding, structuring the project, maybe breaking down the challenges. I'm not sure yet.
Will also be helpful, at least for me, to learn more about Jackal, some introduction or examples, So I've heard about it, but I've never really dived.
So it'd be amazing, Steve, if you could introduce us to one engineer at Tech Quadrant.
Yeah, I could definitely ask. That's a possibility. The other sort of, I think, questions or learnings we could do, I think Mike, you had brought this up the last call, was making sure we're focused on like not being entirely tech driven, I guess. And so like, suppose we did get these separate knowledge graphs connected, what are the kinds of questions that those people in medicine would actually want to ask? So basically have those competency questions guiding the overall work, because then we could build a lot of things and connect a lot of things, which would be fun for all of us, I think, here. But like, so what?
We want to do
like,
something
why?
useful.
Yeah. So like, we could have the list of here are the kinds of, because I know nothing about how genes and proteins interact. Really, I'm learning, but this is like the kind of question that if we could answer it would make a huge difference, using those questions to then guide the things we're developing.
Yeah, some of the FRINK teams, they have those YouTube videos. I think they give some technical overviews, and some of them show some queries in there. So that could be a starting point. Although usually they will have some very sophisticated 2-page Sparkle queries. I'm not quite sure an LLM will be able to do that. But maybe, that we could ask the different FRINK teams to provide us with whatever 5 questions or something like that.
Yeah.
But and I'm not familiar with all the other knowledge graphs either. But what I have done, I just asked the MCP and to go over all the knowledge graphs and ask them what are integration points across those knowledge graphs, and that gave me kind of some ideas. Which knowledge graph have information in it that kind of goes together. Which is not necessarily clear. You won't know that. So you can basically use the MCP to get you some information, which knowledge graphs share some common entities and things of that nature.
On this, I'm really curious, bouncing back on what you just said. At companies that currently have different knowledge graphs and want to leverage them together in a more coordinated way, what you're just saying is probably something very common right now, if they already have knowledge graphs, right? So it's probably a kind of problem that engineers have to solve now. So can we show what we're doing in that light next time? Like, if you want to learn how to connect knowledge graphs, this is an example of how to do it. Would what we do next time be potentially
duplicable, or would it be a learning experience for companies, or does it have to be custom made all the time, or you know what I mean? Mike, for instance, what do you think? Would that be of interest
Yeah.
for people who want to learn how to do that, or is it too unique each time?
I don't think it is. I think Peter formulated it in a really interesting way, is that instead of returning just an ID, we would really want the MCP to receive back a subgraph of information. The information is there. We need to add this extra step, right? This is what I'm getting from Peter, is we need this extra step where you query a knowledge graph, and instead of getting back just a node ID, you would get back a subgraph, for example. Right? That in itself, I think, would probably be it's a general issue that I think everyone has. And it might be of, more general applicability.
Yeah, I think what happened. Yeah, go ahead. Sorry.
No, I was going to say I really like that idea because, I mean, if you look at that list, looks like this NSF funded project has 20 different knowledge graphs, and I'm assuming the way people are building these, they tend to be pretty domain specific, whether we like it or not. And so this idea of there's already this information that's highly curated by experts out in the world. I want to connect a few to answer new questions. If we do that and find out a process, I'm sure there's a lot of manual steps for us to do that the first time, but like figuring out how that would actually works has applications across, I mean, those 20 to start with, but then there'll be more and more.
Yep.
Is this related in any way to compound intelligence for LLM to try to leverage queries from users to the LLM through knowledge graphs?
That's exactly how Peter was phrasing it. It's saying we get the query and we don't get enough information back from the knowledge graph for the LLM to use. Okay, so if our query returned a subgraph instead of just a node ID, then the LLM would have a lot more to work with.
So I think like Neo4j graph, when I was using last or reading something, they already have built some like MCP clients and servers which we can connect, like if we start using it. So is it something that we are using, Mike or Peter? Anyone can help me with?
Yeah, we are using the Neo4j
Yeah.
MCP as well for our MCP knowledge graphs, but the FRINK project is unfortunately all RDF, so that's why we really need to. If we want to help the FRINK project, unfortunately, it needs to be RDF. I'm more from the Neo4j property graph area, so RDF is still a new stuff for me. Just getting warm up with that.
Yep.
I think it is possible to use, but I mean, what we've seen with some of our customers, people love Neo4j. It's really great at some of those like graph analytics use cases. And so what I can imagine is kind of what you just said, Mike, is that do that query, get that graph, you have the subgraph now, you can start asking those questions, but you have all of the content and context to feed the Neo4j instance exactly what you want to be asking it about. Because realistically, you're not going to just dump all of FRINK into Neo4j. So it's like, okay, we need some federated query across them with the right amount of context and relationships to then bring into Neo4j. Like we can do that conversion, but that first step of connecting it all, we could do in RDF because that's what they're based in.
Yep. So it sounds to me like this would be a step beyond just simple federation, which is aligning IDs. So it might be useful. It seems to me like it will be useful.
Yeah.
Does that answer your question, Hugo? About something really specific to tackle?
It does. And at the same time, it will scare some of the learners that we have, I think. Maybe. Someone told me earlier, I'm not coming to the Hacknight because it looks like it's way beyond what I understand. Even though that person seems to be a data scientist, but just not exposed to this probably before. So can we can we think of that problem for people who already know what they're talking about and are at the tip of research kind of, or those who want to follow what they're doing and give a hand, but also maybe another project for those who just want to discover. Is there anything else like really chewable for those who just learn?
Gaston has an idea.
Hey, how's it going? Yeah, I was like doing some mild research for Sparkle and Shackle because I have no idea what those are. And do we have like official like documentation that we can like confide with each other? That way we can like as far as like those two that we're gonna be working with, because I'm more on the Neo4j area, like Mr. Peter Rose. So yeah, if we can work out like just like a mutual, okay, we're going to utilize this documentation or official documentation from Sparkle, Shackle, or a repo from GH, GitHub, whichever one works or is available. Just because I don't want to do research and I'm picking the wrong one, So I just want to make sure we're all like on the mutual same page as far as the R&D goes for everything as well.
Makes sense.
And Shadab, did you want to add anything?
Yeah, pretty much Gaston has covered. So apart from documentation, maybe like to gauge the interest from more participants, we can do pre-workshops before the hack nights, like some resources we can compile and share with them so that they get the idea of like what we are trying to achieve and upskilling them a bit technically on graph side, so that even though if a data scientist or machine learning engineer want to start with this domain or with these kind of problems, they have some base setup so that they're not scared of like what they're getting into.
Okay. Yeah, because I've been mixing up with a lot of object-oriented programming with knowledge graphs and AI. So like I've been getting really creative in that space right now. So
Nice.
yeah, so like I'm like really interested. But as far as that goes, yeah, like I just want to make sure like everyone's like looking up the same documentation and that type of stuff like from like the start. That way everyone can be in sync and it just like it's a good ripple effect. So all right,
That's
cool.
a good idea.
Awesome.
Sounds good. So let me connect again with you on that, the documentation, and how we can make it a resource that everyone has access, can access from the app as well, so that everyone is at the same level. I'm sure there's GitHub involved and things like that, but would love to help this team organize this through the app so that it's really useful, because I'm learning how to do this with you tonight as well. And the Hack Night being a new format for us, like this recurring series of event where we can keep building. There's different people coming today than last time, and then next time is going to be different. Someone cannot make it, so I think this is a crucial aspect, and that's going to help people ramp up with our project and learn. So thank you for that. I'll be back in touch. I'll explore, note all the ideas thanks to the recording. I'll share that with you, validate that hopefully by the end of the week, and then we should be ready next week for the next stage discussions and preparing the next Hack Night.
Yeah, and Hugo, let me know on the Shackle side. I try to take my like top quadrant hat off when I join this Hack Night, so I'm not trying to like push it. But if that is something that we sort of the technology that we're going down, let me know, and I can set up resources in terms of. There's official documentation of Shackle, any additional material, training, anything like that. I can facilitate that, but I don't want to. Try to
No, thank you. I think it sounds very appropriate, and we know you're not trying to push. We appreciate the help, and you're there. So,
yeah, that's like what we do. Okay? So the Shackle's like there is like an owl versus Shackle sort of thing, but there's a use cases for both, and it sounds like some of the use cases that we're talking about, if they lend themselves more to the Shackle side, then that's something that we could definitely facilitate. So yeah, happy to set anything like that up.
Yeah, if you could give us some kind of tutorial or primer, that will be useful in addition to the documentation.
Yeah, absolutely.
Okay, well, that sounds great. I don't know if anyone would like to add anything else. Any last words?
Hugo, I have one question. There's also a meeting on Thursday, and I'm confused because it also mentions Spoke, so I have no idea what that meeting is about.
That's delayed postponed to later in the month. So can you take a screenshot and share what you see with me? You should not see that as on Thursday. Yeah.
Yeah, I'll send it to you.
You might see that in an email, but on the app, you should not see that anymore. And it's been postponed to in 2 or 3 weeks from now. I guess probably the data enhancers, but we'll reconvene, Mike, because what we wanted to do for enhancing Spoke is probably going to be a little bit obsolete. So that's part of the, discovery of all that.
We can just point the same enthusiasm in a different direction.
Exactly. Thank you so much, Mike. Really appreciate
it. I actually just found a toolkit for retrieving subgraphs, which has to do with our conversation. So there are things to look at.
It sounds amazing. Well, thank you, everyone. We hope to be of use, Peter. So thank you for joining, and keep letting us know if you have other ideas of other people in the team who'd like to join. And I'm sorry we couldn't make it to the NSF, actually, because of everything that's happening, government shutdown, but we'd have seen each other, and I'm sure it's in a way everything happens for a reason, and we might be able to support you better. All the demos that you and FRINK and the different projects are working on for the agencies, for others to see, we might help you support that and show even more success for whenever the NSF manages to organize that event. So thank you for joining and letting us help, which is never easy when other people try to chime in. So thanks for that. I appreciate it.
Yeah, sure. Yeah, thanks
everyone. Thanks everyone. Have a great evening.
Bye.
Thanks everyone. Have a good evening.
Thanks.
Bye.
Bye everybody.